Welcome to Learn with Roblox. In today's video, we're going to do absolute value equations. Before I do that though, let's talk about what an absolute value is. So remember, an absolute value takes whatever number you have in there and it makes it positive, no matter what. So for example, if I had 4 in the absolute value, well 4 is already positive, so it just stays 4. What if you had negative 4? If you have negative 4 in an absolute value, the absolute value just makes it positive, so you still have positive 4 at the end. So absolute value just takes anything inside and makes it positive. Now let's talk about how to solve absolute value equations. Let's start with this first one here. It says the absolute value of 3x minus 2 plus 6 is equal to 10. To solve this equation, I'm just going to treat it like any other equation. I'm just going to isolate the absolute value now by subtracting 6 from both sides. And if I do that, I'll have the absolute value of 3x minus 2 is equal to 10 minus 6 is just 4. Now what do we do from here? Well, what you need to realize is that if you have 3x plus 2 or minus 2, this can be equal to 4, but you could also set it equal to minus 4. And why is that? Well, think about it. If you put minus 4 into here, minus 4 in absolute value becomes positive 4. So in other words, 3x minus 2 can be either 4 or negative 4, and the absolute value will transform it into 4. So with absolute value, you have to set the thing inside the absolute value equal to the positive and the negative version of whatever is outside. So let's do that. I'll have 3x minus 2 is equal to 4. I have 3x minus 2 is equal to negative 4. Let's solve both of these. To solve this top one here, just add 2 to both sides. If I do that, 3x is equal to 6. And then you just divide by 3 on both sides. And if you do that, x is just equal to 2. So that's our first solution. And then I'll solve the bottom one here. Add 2 to both sides. And if I do that, I'll have 3x is equal to negative 2. Then just divide by 3 on both sides. So x is just equal to negative 2/3. So these are our two solutions to the absolute value equation. However, when you're dealing with absolute value equations, it's a good idea to always check your answers, and you'll see why we need to do this in future problems, but I'm just going to check the answer really quickly right now. If we plug in x equals 2 into the equation, in the initial equation here, we're going to have 3 times 2, minus 2 plus 6 is equal to 10. Let's think about if that's true. 3 times 2 is 6, so we'd have 6 minus 2, and then 6 minus 2 is just 4. And then the absolute value of 4 is just 4. So this is just 4 plus 6, which equals 10. So that makes sense. That means x equals 2 is a solution indeed. We checked it. Now this is equation with x is equal to minus 2/3. So recall our equation was 3x minus 2 plus 6. So let's put in 2/3 here for x, or negative 2/3. If I do that, these 3's will cancel out and I'm left with minus 2 plus 6 is equal to 10. And is that a true statement? Well, minus 2 is just minus 4. And then minus 4 in an absolute value sign becomes plus 4. So I have 4 plus 6, is that equal to 10? Of course it is. So this means that we verify that x is equal to minus 2/3 is also another valid solution to this equation. So it's always good to check your answers at the end whenever you're dealing with absolute value problems. Let's go to the next problem. This equation says the absolute value of 6x minus 3 plus 7 is equal to 1. To try and solve this, let's subtract 7 from both sides so that we can isolate the absolute value. If I do that, I'll have the absolute value of 6x minus 3 is equal to negative 6. Now let's think about this for a moment. This is saying that an absolute value is equal to a negative number. Can an absolute value be equal to a negative number ever? No, because remember, whenever you have an absolute value, it doesn't matter what number you have in it, it always gives you a positive number. But this is saying that you'll have an absolute value that gives you a negative number. That is not possible because absolute values always spit out positive numbers. Therefore, it doesn't matter what value of x you put in. This equation has no solution. So whenever you have an absolute value equal to a negative number, you automatically write no solution because that's impossible. Let's go to the next one. Let's try solving this one now. It says the absolute value of 2x minus 7 minus 5 is equal to minus 2. So first step is to add 5 to both sides to isolate the absolute value. If I do that, I'll have 2x minus 7 in absolute value signs is equal to plus 3. So now think about it. This whole quantity of 2x minus 7, it could either be 3, because the absolute value of 3 is just 3, or it also could be negative 3. Because if you put negative 3 into absolute value, it becomes positive 3, which would satisfy this equation. So I'm going to set 2x minus 7 equal to both 3 and minus 3 and solve those separately. So let me do that. So first, I'm going to solve 2x minus 7 is equal to positive 3. Add 7 to both sides, and that's 2x plus 10, or equals 10. And then just divide by 2 on both sides. And if you do that, x is equal to 5. So that's one solution. And then I'm going to find the other solution now. So let's set 2x minus 7 equal to negative 3, because that can also get a solution for us. Add 7 to both sides. 2x is equal to 4 then. And then if you divide by 2 on both sides, x is just equal to 2. So now let me just write both of these solutions out. We now have that x is equal to positive 5 and positive 2. Now remember, I said that for absolute value equations, it's always good to check your answers. So let me just do it really quick. Let's test 5 first. If I test 5, that'll be 2 times 5 minus 7 in absolute value minus 5 is supposed to be negative 2. So this would just be 10 minus 7, and 10 minus 7 is just 3. So we have the absolute value of 3 minus 5 is equal to negative 2. Absolute value of 3 is just 3. And then 3 minus 5, is that equal to negative 2? It is. So that means this works out. X equals 5 is indeed a solution. Let's check off the x equals 2 now. If I do 2 times 2 minus 7 minus 5 is equal to negative 2. 2 times 2 is just 4. 4 minus 7 is negative 3. And then negative 3 in absolute value becomes positive 3. And we're back to 3 minus 5 is equal to negative 2, which is indeed true. So therefore, x equals 2 is also a valid solution. So these are both of our answers. Let's go on to a harder one. This example says the absolute value of x minus 7 plus 3x is equal to negative 3. To solve this, subtract 3x so I can isolate the absolute value. That gives me x minus 7 in absolute value is equal to minus 3 minus 3x. Now your first instinct might be to say that, okay, we're setting an absolute value equal to a negative number, therefore this is impossible. But notice, if I had a big negative number for x, this equation could actually become positive on the right side. So in that case, the equation is solvable. So we can't quit just yet. We need to keep going forward. So how can you solve this equation? Well, remember, if I had something like x minus 2 is equal to 3, what I could do is just say this whole thing's equal to the positive version of the number or the negative version of that number. Well, remember, minus 3 minus 3x at the end of the day is just a number. So what I can do is set it equal to the positive version of this or the negative version of that. In other words, I'm going to set up two equations. Let's say x minus 7 is equal to the positive version of that, which means I just keep it as it is. Or I can make the whole thing negative, and that'll give me a new equation. So I'll have x minus 7 is equal to minus 3 minus 3x. And these are two separate equations that we can use to solve for x, and then check the solutions at the end. So I'm just going to solve this first one at the top really quickly, and then I'll do the next one. To solve this, add 7 to both sides. So that's x is equal to minus 3 plus 7 is 4, and then you have minus 3x. And then just simply add 3x to both sides. And if I do that, I'll have 4x is equal to 4, which means that x is simply just equal to 1, because you divide by 4 on both sides. So let's save this solution so we can check it at the end. I'm just going to erase all of this here. And I'm going to write x is equal to 1 at the side here, so we save that solution. Now I need to set x equals 7 to the negative version of whatever this is. So is equal to negative 3 minus 3x. If I distribute the negative sign, that becomes 3 plus 3x. To solve for x, subtract 3 from both sides. Then I'll have x minus 10 is equal to 3x. So just subtract x from both sides now. And if I do that, I'll have minus 10 is equal to 2x. Just divide by 2 on both sides now. Oops. And if I do that, I'll have minus 5 is equal to x. So now we have two solutions. We have x equals 1 and x equals negative 5. But what if both of these solutions aren't actually correct? Why don't we try checking our answers and see if both these are correct or only one of these is correct? So first, let's check x equals 1. If I plug that into our initial equation, let me just erase all this so you can see it. That's 1 minus 7 plus 3 times 1 is just 3 is equal to negative 3. Now let's see if this is a true statement. 1 minus 7 is negative 6 plus 3 is equal to negative 3. Well, the absolute value of negative 6 is just positive 6. And if you add that to 3, that is not equal to negative 3 because 6 plus 3 equals 9. Therefore, this does not work out. That's not true, which means that x equals 1 is actually a fake solution. So now we only have x is equal to negative 5 remaining. Let's check if this is a valid solution to our equation. So let's set this up. I'll have minus 5 minus 7 in absolute value plus 3 times minus 5. And we want to verify that this is equal to negative 3. Minus 5 minus 7 is minus 12 in absolute value. And then 3 times 5 is just, or 3 times negative 5 is negative 15. And this thing's supposed to be equal to negative 3. Minus 12 in absolute value just becomes positive 12. And then 12 minus 15 is just negative 3. So notice we got negative 3 equals negative 3. That makes sense. That's a true statement. Therefore, x equals minus 5 is a true answer. So notice how we got two answers from this absolute value, but only one of them was true. So this is why it's important to check your answers at the end when solving absolute value equations. Let's look at another similar one. Let's solve 7x minus 3 is equal to the absolute value of 2x plus 15. To solve this, recall that if I just had a random isolated absolute value like x minus 3 is equal to 2, you could say this whole thing's equal to 2 or negative 2, because a negative 2 in an absolute value would turn into positive 2. So let's use a similar idea. I'm just going to say this whole thing is either equal to 7x minus 3, or it could also be equal to the negative version of that. So let's set up equations where 2x plus 15 is equal to this one and that one. What in the world? Why is this not erasing? Okay, there. So now I'll have 7x minus 3 is equal to 2x plus 15 as one equation. And I'll have negative 7x minus 3. If I simplify that, that's minus 7x plus 3 is equal to 2x plus 15. Let's solve both these equations to get solutions to x and then verify both of those solutions to see if both are true or if only one is true. I'll solve this first one at the top. So I'm going to write it down here. 7x minus 3 is equal to 2x plus 15. So add 3 to both sides. That gets you 7x is equal to 2x plus 18. Subtract 2x from both sides. And I'm just going to rewrite this here. That gets you 18 is equal to 5x, because 7 minus 2 is 5. Divide by 5 on both sides, and you get that x is equal to 18 fifths. So that's one solution we'll need to check. I'm just going to write that this leads to 18 fifths as a solution. Then now let's solve the other one. So let me just rewrite it. We have minus 7x plus 3 is equal to 2x plus 15. Subtract 3 from both sides. And that gets you minus 7x is equal to 2x plus 12. Then subtract 2x from both sides. And if you do that, you'll get 9x, negative 9x actually, is equal to 12. From here, just divide by negative 9. And if you do that, you'll have x is just equal to 12 over negative 9. If you want to simplify that, that's 4 over negative 3, or we can just rewrite this as negative 4/3. So now we have the solutions to x. We just need to verify them to see if both are true or if only one is true. So let me just write that this equation got us negative 4/3 as a solution. So now let's verify the 18th solution first. To verify that, let me write the initial equation. We have 7x minus 3 was equal to the absolute value of 2x plus 15. So just put in 18 fifths to check your solution. I'll have 7, and then 18 times 18 fifths minus 3 is equal to 2 times 18 fifths plus 15 in absolute value. And then 7 times 18, if you do that on a calculator, that's 126. So I have 126 over 5, and then minus 3. I can write that as 15 over 5 by multiplying both the numerator and the denominator just 1, by 5. And this has to be equal to 2 times 18 fifths is just 36 fifths. And then to write 15 as something divided by 5, I can just do 15 times 5 divided by 1 times 5. And that gives me 75 fifths. And then let's just check this. 126 minus 15 is 111 divided by 5. And this is equal to the absolute value of 36 plus 75 is also 111. And then you have divided by 5. And then it's a true statement. Well, yes, because the absolute value of 111 or 5 is just 111 over 5. So this is a true statement. Therefore, our solution of 18 fifths is a true solution. Now, let me erase all this work down here, and then what we can do is, we can verify the minus 4/3 to the solution to see if it's true or false. So we have 7, and then times minus 4/3 minus 3 is equal to the absolute value of 2 times negative 4/3 plus 15 in absolute value. So then let's look at the left side first. 7 times negative 4/3 is negative 28 over 3. Well, I want you to know that this left side is just a negative number, because minus 28 over 3 minus 3 is just a big negative number. Can an absolute value be equal to a negative number? No, that's impossible. So therefore, I know that this 4/3 or negative 4/3 is actually a fake solution. In other words, the only solution I have is 18 fifths. So I'm just going to erase all this here to write down our final solution. Our solution is x is equal to 18 fifths, because we had two solutions, but one of them turned out to be false. And this is why it's important to check your answers when solving absolute value equations. Let's go to another one. This equation says 3 times the absolute value of x minus 3 plus 5 is equal to 20. To solve this, let's subtract 5 from both sides. Now we have 3 times x minus 3 in absolute value signs is equal to 20 minus 5 is just 15. Let's just divide by 3 now. And if I do that, I'll have, this is just equal to 5. And these 3's cancel out. So I just have the absolute value of x minus 3 is equal to 5. What that means is that x minus 3 can either be 5, but it could also be negative 5, because negative 5 absolute value becomes 5. So let's set up two equations. I'll have x minus 3 is equal to 5. X minus 3 could also be equal to negative 5. To solve both these equations, just add 3 to both sides. And if you do that, the left side will have x equals 8 as a solution. This right equation will have x equals negative 2 as a solution. So now we have two solutions. Let's just check them really quick. So I'm just going to erase all this scratch work so we can check them. So recall our solutions were 8 and negative 2. Let's just test these and see if both are true. So let's test the first one out, 8. So I'll have 3 times the absolute value of 8 minus 3 plus 5 is equal to 20. Is that a true statement or not? 8 minus 3 is just 5. The absolute value of 5 is just 5, and 3 times 5 is just 15. Does 15 plus 5 equal 20? Of course it does, which means that 8 is a valid solution. So I'm just going to say 8 is true, but what about negative 2? We need to check if that works as well. So we have 3 times the absolute value of minus 2 minus 3 plus 5 is equal to 20. 2 minus 3 is, or minus 2 minus 3 is minus 5. Minus 5 in an absolute value becomes positive 5. So you have 3 times 5, which is just 15, plus 5 is equal to 20. Is 15 plus 5 equal to 20? It is. So therefore, we know that minus 2 is also a valid solution. Therefore, x is equal to 8 and is equal to negative 2. This equation says the absolute value of 6x minus 1 plus the absolute value of 5x minus 3 is equal to 4. What in the world do I even do here? There are two absolute values to work with. What you have to do is you have to consider all possible cases, and when there's two absolute values, there's a different way to think about the possible cases. The first equation you can solve is, let's say I keep 6x minus 1 and I keep it positive so I don't change it, and then 5x plus 3 or minus 3, let's say I also keep it positive so I don't change its sign, I keep it as 5x minus 3. That gives me one equation. What I can also do is, let's say I keep 6x minus 1 as 6x minus 1, keep it positive, and then I flip the sign on 5x minus 3, so I take the negative version of that. I can also take the negative version of 6x minus 1 and the positive version of 5x minus 3. And then our final possible case is we make both of them negative. So what you're going to have is 4 equations leads to 4 solutions of x, and then you have to test all of those solutions to see which ones are valid, because some might not be actual solutions. I know this sounds like a lot of work, but unfortunately that's what happens when you have lots of absolute values in one equation. So let's just do this. I'm first going to consider the case where both 6x minus 1 and 5x minus 3 are unchanged, the positive case. I'm just going to write down plus plus. So here we have 6x minus 1 plus 5x minus 3 is equal to 4. I'm just going to quickly solve this. This is 11x minus 4 is equal to 4. If I add 4 to both sides, that's 11x equals 8. And that gives me x is equal to 8 over 11. So first I'm going to erase all this here, and then I'm going to write 8 11ths next to the positive solution and say this gives me 8 over 11. That's one solution to test out. Now let's go into the positive 6x minus 1, then you flip the sign on 5x minus 3 and see what that gets us for a new equation to solve. I'm going to write plus, comma, minus. So here we have 6x minus 1 plus, you have negative 5x plus 3, because you flip the sign on both of them, is equal to 4. So now we're going to have 6x minus 5x is just x, minus 1 plus 3 is plus 2. So then that means x is just equal to 2. So I'm going to erase all this down here. And I now have that if we do plus minus, x equals 2 as our solution. Now we need to think about the minus plus case. So what I'm going to do is do 6x minus 1 and make it negative. So that's actually minus 6x plus 1 plus 5x minus 3 is equal to 4. So to solve this, you'll have that's minus x. If you do minus 6 plus 5x, then 1 minus 3 is just minus 2 is equal to 4. And then we'll have minus x is equal to 4 plus 2 is just 6, because I added 2 to both sides, which means x is just simply equal to negative 6. So that's another solution. So let me just say that this gives us minus 6 as a solution. And then consider the both negative case. So that means we'll have, let me just erase it down here. We have minus 6x plus 1, because I flipped the sign on both of those, plus minus 5x plus 3, because I flipped the sign on both the 5x and the minus 3, is equal to 4. If we do this, we're just going to get that we have minus 11x plus 4 is equal to 4. Subtract 4 from both sides, and then you have minus 11x is just equal to 0. Well, if minus 11x is equal to 0, x just must be 0. You can also divide both sides by negative 11, and then 0 divided by negative 11 is just equal to 0. So this case gives that 0 is equal to x. So now let's go back to the top. This gave us x is equals 0 as a solution. What I need to do now is test each and every one of these solutions into the initial equation and see which ones are correct and which ones are fake solutions. Let's start with 8 11ths first. I'm going on here and just write the whole thing. We have 6 times 8 over 11 minus 1 absolute value plus 5 absolute value of 5 times 8 elevenths minus 3 has to be equal to 4. So if we do this, we'll have 48 divided by 11, because 6 times 8 is 48, minus, I'm going to write 1 as 11 over 11, absolute value, plus 5 times 8 is 40 over 11. Then minus 3 is just minus 33 over 11 if you multiply 3 by 11 and add an 11 to the denominator. And we want to see if this is equal to 4. Okay. 48 minus 11 is just 37 over 11. So that's an absolute value signs. And then 40 minus 33 is just 7. So I have 7 over 11. Both of these are positive numbers, so the absolute value does nothing to them. I'm just going to write 37 over 11 plus 7 over 11. Is that equal to 4? 37 plus 7 is 44. So that gives us 44 over 11. Okay, well 44 divided by 11 is 4. So all that work proved that 4 is equal to 4. Therefore, the solution of 8 elevenths is true, because when you put it back into the equation still stands. So therefore, I'll put a check mark on this one. Now let me just erase all this work down here so we can verify the next one, or see if it's false. The next one we need to verify is the solution x is equal to 2. So let's do this. I'll have 6 times 2 minus 1 plus the absolute value of 5 times 2 minus 3. Is that equal to 4? So 6 times 2 is just 12 minus 1. And then 5 times 2 is just 10, and we have minus 3 equal to 4. So 12 minus 1 is 11. And then 10 minus 3 is just 7. Well, notice both these are positive numbers, so absolute value does nothing. So you have 11 plus 7. Is that equal to 4? Of course not, because 11 plus 7 is 18. Therefore, because we proved that putting in the solution x equals 2 gives us a false statement, we know that x equals 2 is not actually a solution to this. So we'll put an X mark there. Let's test the minus 6. I'll have the absolute value of 6 times negative 6 minus 1 absolute value plus 5 times negative 6 minus 3. Is that equal to negative 4 or positive 4? So 6 times negative 6 is just negative 36. We have minus 1 plus 5 times negative 6 is just negative 30. Then minus 3. Is that equal to 4? So we have the absolute value of minus 37 plus the absolute value of minus 33. Is that equal to 4? Well, no, that's not the case. Because let me just continue to do this. We'll have 37 plus 33, because absolute value make those numbers positive. Is that equal to 4? No, not at all. So therefore, we know that the solution of minus 6 is actually a fake solution. So let me just go up and put an x next to it. So x equals negative 6. That's not true. So now let's use 0 now and see if that solution is true. We'll have 6 times 0 minus 1 absolute value plus 5 times 0 minus 3. Is that equal to 4? Well, 6 times 0 and 5 times 0 is just 0. So we just have 0 minus 1 plus 0 minus 3, both of those in absolute value signs, is equal to 4. Well, that's just minus 1 in absolute value plus minus 3 in absolute value is equal to 4. Well, minus 1 and minus 3 turn into plus, and 1 and plus 3 with an absolute value. So is 1 plus 3 equal to 4? Yes. So that means 0 is actually a solution to this equation. So in other words, we had 4 solutions, we checked all those off, and the only ones that remained are 8 elevenths and x equals 0. So let me just erase all this work and then write down our final answer. So our final answer is x is equal to 0 and is equal to 8 over 11. That was a ton of work. This problem says the absolute value of x minus 3 is equal to the absolute value of 2x minus 1. To solve our x, we need to consider 4 cases, because this is another problem that has 2 absolute value signs in it. The 4 cases are, first, you can either keep the sign on x minus 3 and not alter it, so I'm just going to write a positive for that, and you don't alter the sign on minus 2x plus 1, so you keep it as it is. You can also keep the sign on x minus 3, but also change the signs on minus 2x plus 1, so you apply a negative sign to both of those terms. Or we could apply a negative sign to both the x and that minus 3, and then keep minus 2x plus 1 as it is. Or we can flip the signs on both of those things. And this gives us 4 unique cases to solve. So we need to find the solution in each of these cases and then test all the solutions to see which ones are true and which ones might be false. So first, let's do the case where I don't alter any of the signs. I just keep it as it is and then remove those absolute value signs. So first, I'll write plus, comma, plus. This gets us x minus 3 is equal to minus 2x plus 1. So then to solve this, just add 3 to both sides. That's x is equal to negative 2x plus 4. Add 2x to both sides. And that gets me 3x is equal to 4 divided by 3 on both sides. And therefore x is just equal to 4/3. That's the solution I'm going to want to save for later. So now let me go up to the top and write down this gives us that x is equal to 4/3. Now I'll try the case where I keep x minus 3 the same, but I change the signs on minus 2x plus 1. So I'm going to write plus minus here. So that gives me x minus 3 is equal to, I'm going to put a negative sign in front of everything, minus 2x plus 1. If I distribute that negative sign to both terms, that gives me positive 2x minus 1. Let's solve for x. I'm going to subtract x from this side. And I'll have minus 3 is equal to 2x, or that's just x minus 1. So just add 1 to both sides and we're done. So therefore, minus 2 is equal to x. That's another solution to save and think about. So this gives us x is equal to negative 2. Now let's do the plus minus, or the minus plus case, where I'm going to change the sign on x minus 3 by applying a negative to both of those, but I keep the sign on negative 2x plus 1. So this will give me minus x plus 3 is equal to minus 2x plus 1. So just add 2x to both sides now. And I'm going to have x plus 3 is equal to 1. Subtract 3 from both sides, and you have x is equal to negative 2. So notice that just gave us the same answer as the previous equation. So I'm just going to up here and say this one also gives you that x equals minus 2. And now let's do the minus case where I flip the signs on both of those absolute value terms. So I have minus x plus 3 just from last time. And then if I flip minus 2x plus 1, that's 2x minus 1. And if we solve this, I'm just going to add x to both sides. And I'm also going to add 1 to both sides in just one step. So I have 4 is equal to 3x. Well, wait a minute, that just gives us 4/3 for x. So notice that also gave us the same solution as the case where I kept both of the signs the same. So I'm just going to say that this gives us x is equal to 4/3. So notice there's only 2 solutions we need to test actually. We just need to test 4/3 and 2, or negative 2, to see which one is true and which one is false, or maybe both of them are true. So let's test 4/3 first. To test that, I'm going to write, we have 4/3 minus 3, because we have x minus 3, is equal to negative 2 times 4/3 plus 1. So let's see if this is true. Well, we have 4/3 minus 3 is just 9/3. And that's equal to minus 2 times 4 is negative 8/3. Plus 1 is just 3/3. So now that gives us minus 5/3 over here equal to the absolute value of minus 5/3. So notice, because we have the same thing inside the absolute value signs, this equation is true. In other words, x equals 4/3 is a valid solution. Now let me erase all of this here, and then put a check mark on x equals 4/3. And then now let's do x equals minus 2 and see if that works out. So let's do this. We have minus 2 minus 3, because you just put in minus 2 for x, is equal to minus 2 times minus 2 plus 1, absolute value. And let's see if this is true. Minus 2 minus 3 is minus 5. And then minus 2 times minus 2, which is positive 4, plus 1. So in other words, we have the absolute value of negative 5 is equal to the absolute value of positive 5. And this is a true statement because an absolute value just makes both of those things positive. So you'd have both positive 5 at the end for both sides of this equation. Therefore, we know x equals negative 2 is a true answer. So in other words, I'm just going to erase all this here. Our final answer is that x is equal to 4/3, and it's also equal to negative 2. So this time, when we checked our answers, we found that both of them were valid. We did not need to cross any answers off. If you enjoyed this video, please consider leaving a like and subscribing. Thanks for watching.